think that's
Super.
my cue to start sharing slides.
That is, and we will have these slides associated below in the links, so you'll be able to access these slides as well. So do not worry.
And Priya, will you also speak to, maybe not today, but in a future session, the relationship between machine learning and AI, and how what's the break-off, and what are the different use cases for these different approaches?
Yeah, so I think that's actually a great preemption for my first slide here. So yeah, so what is machine learning? And exactly, when we talk about machine learning, we do want to talk about what artificial intelligence is first. So artificial intelligence really refers to any algorithm that allows a computer to perform a complex task. Sometimes these are tasks that we associate with human intelligence, so speech or reasoning or vision, but sometimes they're not, right? Machine learning and AI are used to predict solar power output. That's not canonically something a human would do. So really, it's just any task that's a complex task. And as I mentioned, kind of initially when AI started, it really was about just writing down a formal set of rules and figuring out some way to reason over those sets of rules. But today, we've seen a huge surge in machine learning, and machine learning is a subset of artificial intelligence. And it specifically refers to techniques that automatically extract patterns from data, and usually large amounts of data. And so because machine learning has become such a kind of dominant paradigm within AI, you'll actually hear these terms used interchangeably quite often, and I'll do that often as well, kind of interchangeably use AI and machine learning. But AI is actually a bit of a broader concept that encompasses symbolic techniques, other kinds of techniques, like physics-informed techniques, things like that. Whereas machine learning is specifically kind of data-driven analysis, automatic data-driven.
So can I ask you a layman's question? So for example, think of a big insurance company with all the data that they have access to, all sorts of things that they insure and things that go wrong, like the analysis of their data set to figure out how to price their premiums and how to, create their products. I assume that would be using more of a machine learning subset of technology rather than, I guess we wouldn't call that artificial intelligence. But when I do ask a question to ChatGPT and get a page of text as answer, it could be analyzing a key character from a play, and is that called artificial intelligence?
Yeah, so I'd say both of those things are machine learning, and as a result, both of them are also artificial intelligence, in the sense that even GPT, and I'm sure we'll get into this more later on, all it's doing is analyzing some structure in its underlying data and parroting that back out. So there's actually this famous paper, Stochastic Parrots, which describes these kinds of models as basically models that really try to understand or analyze or learn some kind of structure or pattern in the underlying data. And then with some random probability distribution, basically just spit something out that looks kind of like that. And so that, even though it seems more intelligent on the other side, it's actually not inherently any more intelligent than just doing large-scale analysis of your insurance data. It's actually something very similar under the hood.
Got it. They are kind of making it look like it's different, like it could be different every time you ask the question. I guess there's some sort of variable in there that causes it to come slightly different every time.
Yeah, and that's the stochastic in Stochastic Parrots. Basically, as you put in certain kinds of data, there is some kind of randomness in terms of kind of what spits out.
Yeah, makes sense.
But Karim, you've raised a good, very climate solutions focused solution, which is insurance, because with increases in extreme weather, you're going to have new underwriting requirements.
But that takes me to the parroting word that Priya just mentioned, because each extreme event is more extreme than the previous. At least it seems so in our life.
Right. So looking exclusively at historic data is not going to work. So you have to take the next step, which is predictive.
Right. And how is that going to be? So are those coming out accurate? I guess is the question.
Exactly. And that is the real question. And this is where this kind of, area of kind of physics informed or knowledge informed machine learning comes into play. So for example, if you're an insurance company that's trying to predict what climate risk will look like in the future, one thing you could do is just try to learn from your current weather data using a machine learning model and predict that out. But as you're observing, because the data you're learning from is fundamentally different than sort of the situation going forward, you're not going to get that. But what people have done is do things like say, I have a climate model that has my physics written down, but there are some parameters in there where I don't know what the exact value should be. And so can I actually use data to inform what the parameters of my climate model are? And that climate model, it's the physics that will continue to persist. That climate model can actually generalize and make predictions we can trust in the future. So I'm increasingly a big fan of these, knowledge, domain informed, physics informed, knowledge informed approaches, as opposed to just scraping a bunch of random data from the internet and hoping something emerges from that.
Yeah, sounds good. All right, please continue.
Yeah.